Let us now briefly discuss the solution. I'm sure that at this point you would have written down the correct statements easily. You would have also downloaded the solution as well. Unless necessary, I won't distinguish between MATLAB and Python, even though I am using the MATLAB user interface. In Task 1, the idea is simply for you to learn that the argument of the sine function in MATLAB and Python should always be in radians. Task 2 teaches us how to convert from degrees to radians and vice versa, just in case you need to. Task 3 utilizes the Taylor series at a specific value of the sine function. The more terms we use and sum up in the Taylor series, the more accurate the result is, and the less the value of the percent error is. Task 4 warms you up to the main task in Task 5 by letting you plot the sine function for 3 periods. Finally, Task 5 utilizes the Taylor series for all points in the sine function. Again, we observe that as the number of terms included in the series are increased, the more the exact graph and the approximated graph become very similar to each other, which means that the error decreases as well. Now let me scroll back to the first section. You may have noticed that we can use the MATLAB Livescript and the Jupyter notebook as some sort of a notebook where we can write down equations and make comments. On top of this, we can incorporate our programs or codes in them. This is very neat because everything is in one place. How do you make notes and make equations? In MATLAB Livescript, it's rather easy. Just click on the Insert tab. On the menu, click the Equation button, and you're good to go. For the Jupyter notebook, well, you would need to have some knowledge in a program called Latex. If you need to learn Latex fast, you could do two things. First, you can just double-click on one cell of the Jupyter notebook that you already have with you. You'll see a lot of weird commands. First, let me point out the dollar signs. In between the dollar signs, you have all your equations. So if you want to write an equation, type a dollar sign, type your equation, and then end the equation with another dollar sign. If you want to write a fraction, you need to type in the dollar sign, /frac, and then two pairs of curly brackets next to each other. You put the expression for the numerator in the first pair and the expression for the denominator in the second pair. Type the second dollar sign and then press Shift Return. To create a next line or an indent, just press or type in then press Shift Return. You can try all of these out and figure out how they work. The second thing you can do is search the commands on the internet. I'm giving you one link that will help you figure out which commands to use if you want to set up equations in Python. Of course, there's a multitude of resources available for you that will teach you how to use Latex. One last thing about Latex. It also works in MATLAB. I'd like to show you one more feature that is unique to MATLAB. One of the things that you did was to change the value of the variable m, where m dictates the number of terms in the series. So if m equals 1, then there are 2 terms. And if m equals 5, then there are 6 terms. To change from 1 to 5 and see the result, I needed to delete 1, change it to 5, and then run the whole program again. There's a faster and more convenient way. It's also very cool. First, let's delete the number. Without moving the cursor, I'm going to move my mouse to the Live Editor tab and then click on Control in the code box. Then I click on the numeric slider. A window will pop up that will allow me to change the minimum and the maximum values, the step size, and when I need the output to change. I can also run just the current section or run all sections after moving the slider. Now you see that the slider appears. Let's see what happens. You can see that if I move the slider, you can immediately see the result. Compare between the exact sine function and the Taylor series approximation. I can edit the features here, change it to all sections so that it runs the whole section whenever I change the value in the slider. Okay, so if I do this, then I have m equals 10. And then I do this, I have m equals 11. And here's m equals 13. It's m equals 15. Or 16. And then m equals 20. Now, how cool is that? You can play around some more, have a go with the program, change some variables, use other types of control, and try to set up new equations with Latex.